ही गाइस, आज का वीडियो में तुम लोग को ऑस्मोसिस, रिवर्स ऑस्मोसिस एंड ऑस्मोटिक प्रेशर के बारे में समझाऊंगा। ये वीडियो अच्छा लगे तो शेयर करना, सब्सक्राइब करना एंड लाइक करना।
The today topic is osmosis, reverse osmosis, and osmotic pressure. What is osmosis? The spontaneous flow of solvent molecules from lower concentration to higher concentration. Okay, the spontaneous flow of solvent molecules from lower concentration to higher concentration or from pure solvent to solution through a semi-permeable membrane. Solvent molecules from lower concentration to higher concentration or from pure solvent to solution through a semi-permeable membrane is known as osmosis. Okay. And what is semi-permeable membrane? The semi-permeable membrane the membrane, semi-permeable membrane. These are the membranes through which only solvent molecules pass through this membrane, but not solute. Only solvent molecules due to small size. So due to small size, only solvent molecules pass through the membrane, but not solute. Solute, why solute does not pass through it? Because solute has larger size. That's why it cannot enter to the pore of the membrane. And example, that is the thin layer inside the egg. Thin layer inside the egg. एग का जो अंदर है पतला वाला, जो ऊपर थिक वाला कवर है व्हाइट वाला, उसका जस्ट नीचे पतला सा लेयर एक रहता है, वो है सेमी परमेबल मेम्ब्रेन. ओके, थिन लेयर इनसाइड द एग. ओके. नेक्स्ट, किप्रिक फेरोसियानाइड. किप्रिक फेरोसियानाइड. Great. Kipric ferrocyanide, Cu2 Fe CN6. Okay, Cu2 Fe CN6. Kipric ferrocyanide. This is also semi-permeable membrane. Okay. Next, reverse osmosis. What is reverse osmosis? The flow reverse means it is opposite to osmosis. That means here solvent molecules flow from higher concentration to low concentration by applying high pressure. Okay. It is reverse osmosis means the direction of flow of solvent is opposite to osmosis. So here the flow of solvent molecules from higher concentration to lower concentration through semi-permeable membrane by applying higher pressure than osmotic pressure. On the higher concentration side. Okay, the flow of solvent molecules from higher concentration to lower concentration. Now here, the direction is opposite from higher to lower. In osmosis, the direction is from lower concentration to higher concentration. But here, reverse osmosis, by applying high pressure at the higher concentration side, then the flow of solvent will be from higher concentration to lower concentration. Since direction is opposite, that is higher concentration to lower concentration, that's why this is known as reverse osmosis. Okay, this is known as reverse osmosis. Okay. The flow of solvent molecules from higher concentration to lower concentration through semi-permeable membrane by applying higher pressure than osmotic pressure on the higher concentration side is known as reverse osmosis. Next, what is osmotic pressure? Okay, osmotic pressure means here the flow stops. The pressure, by applying the pressure on the higher concentration side, the flow stops. Okay, the pressure at which the flow of solvent molecule stops. That means it neither moves from lower to higher or higher to lower. This pressure is known as osmotic pressure. Okay, the pressure at which the flow of solvent molecule stops by applying this pressure on higher concentration side is known as osmotic pressure. Then the Manoff Law dilute solution. Then Boyle-Manoff Law. The law states that the osmotic pressure of any solution is directly proportional to concentration of solution or inversely proportional to volume of solution at constant pressure. Sorry, at constant temperature. At constant temperature, the osmotic pressure is directly proportional to concentration of the solution or inversely proportional to volume of solution. So pi is the osmotic pressure, pi is directly proportional to concentration, or pi proportional to C equal to N by V. We write N by V. Concentration equal to number of moles per unit volume. The number of moles per liter. Concentration means moles per liter. That is N by V. Okay. So pi proportional to C or pi proportional to N by V. Okay. So here pi directly proportional to C, and here pi is inversely proportional to V. This equation is 1. Okay. Boyle-Manoff law states that at constant temperature, the osmotic pressure is directly proportional to concentration of the solution. Concentration of the solution, or inversely proportional to volume of solution. That's why pi is directly proportional to C or pi proportional to N by V. Then next is Charles-Manoff Law. Charles-Manoff Law. This law states that the osmotic pressure of any solution is directly proportional to temperature. Okay, directly proportional to temperature if concentration remain constant. So here the osmotic pressure is directly proportional to temperature in Kelvin scale. Temperature in Kelvin scale. We can say absolute temperature. Okay, absolute temperature if concentration remains constant or volume constant. If concentration is constant. Okay, osmotic pressure is directly proportional to temperature in Kelvin scale. Okay, if concentration is constant. If concentration is constant. Okay. So here pi proportional to T. Mathematically, pi proportional to T. Pi is your osmotic pressure, T is temperature at Kelvin scale. Okay. By combining two equations, equation 1 is pi proportional to N by V or pi proportional to C. By equating this equation, so pi proportional to N by V, your equation 1, and pi proportional to T is your equation 2. By combining both equations, so pi proportional to Nt by V, or that implies to remove proportionality sign, then we add a constant, okay, that is gas constant, that is R, Nt by V, or that implies pi equal to Nt by V. So here N by V equal to concentration. That implies P equal to CRT. This is the desired equation. Okay. For I factor, you have to write pi equal to I into CRT. That is Manoff factor I. Pi equal to I CRT. Okay. This is the desired equation. If we know concentration, temperature, and I factor, we can calculate osmotic pressure. Okay, from this equation, we can calculate osmotic pressure. Next, isotonic solution. What are isotonic solutions? Isotonic solutions. Iso means same. Iso means same. Sorry, same osmotic pressure. Same osmotic pressure. Okay. Same osmotic pressure. If two solutions have same osmotic pressure, if two solutions have same osmotic pressure, then the two solutions are called isotonic solutions. Okay. If two solutions have same osmotic pressure, then the two solutions are called isotonic solutions. Okay. So isotonic solution means both solutions have same osmotic pressure. Okay. Isotonic solution means those two solutions have same osmotic pressure. When two solutions are said to be isotonic solutions, if they have same osmotic pressures. Okay. How to solve problem? Pi equal to ICRT. We know that C equal to N by V. C equal to N by V RT. And we know that N equal to WA by MA, number of mole equal to weight by mass, molecular mass, or here atomic mass or molecular mass. Okay. WA equal to MA. So I into WA by MA into V in liter, or equal to 1 by 1000 by V in ml into RT. To solve problems, this equation is required. Pi equal to I into WA by MA into 1000 by VML into RT. Okay, because 1 liter equal to 1000 ml. That's why we, instead of V, we put 1000 by VML. Calculate the osmotic pressure of solution obtained by dissolving 30 grams of glucose in water to form 1 liter solution at 27 degrees Celsius. R is given. Okay, here weight of glucose is 30 grams. Okay, weight of glucose, it is WA, weight of solute. WA equal to 30 grams. Okay, then MA, molecular mass of glucose, molecular formula is C6H12O6. So here 6 carbon. So 6 carbon is 12 into 6. Atomic mass of carbon is 12. Hydrogen, atomic mass is 1. So 1 into 12. And oxygen atomic mass is 16. So 16 into 6. 12 6 are 72 plus 12 plus 96. Equal to how much? 180. Okay, it is 180. Then V equal to 1 liter, or we can say 1000 ml. R also is given. Temperature. Temperature is 27 degrees Celsius. You have to convert it into Kelvin scale. So you have to add 273. That is 300 Kelvin. Okay. Formula is, here I factor is 1. Here I factor 1. Because glucose cannot ionize. Okay. So it is 1. So formula is pi equal to I into WA by MA into 1000 by VML into R into T. So I equal to 1. W equal to 30 gram. And MA is 180 gram. Then 1000 by V in liter is 1000 into R is 0.0821 into T is 300 Kelvin. Here 6, 100, 2. Then I have to multiply 0.0821 into 100. That is 8.21 by 2 equal to 4.105 50. This is your answer. 4.105 atm. Calculate the osmotic pressure of a solution obtained by dissolving 57 gram Al2SO4 whole 3 aluminum sulfate in water to form 500 ml solution. Okay, here solute is aluminum sulfate. Here weight of solute is 57 gram. First we have to calculate I factor. So Al2SO4 whole 3, if it dissociates in water, then it converted to 2Al3 plus 3 SO4 2 minus. Your I factor is your 2Al3 plus, so one molecule Al2SO4 whole 3 is converted to 5 ions. 2Al3 plus ion and 3 SO4 2 minus ion. So I factor equal to 5. And Wa, weight of solute, that is aluminum sulfate, equal to 57 gram. And molecular mass of aluminum sulfate, how much? Aluminum atomic mass is 27 into 2 plus SO4 whole 3, S into 3, sulfur mass is 32 into 3, and oxygen mass is 16 into 4 3 is 12, 16 into 12, equal to 54, 32 3 is 96 plus 16 into 12, that is 192, equal to how much? 4 6 2 1 1 9 10 9 19 5 4 342. And then V is given that V equal to 500 ml. VML equal to 500 ml and temperature equal to 127 degrees Celsius. We have to convert it into Kelvin. So 127 plus 273 equal to 400. Okay. And R is 0.082 liter ATM mole inverse Kelvin inverse. So phi equal to R into WA by MA into 1000 by VML into RT. I factor equal to 5 into WA. For WA it is 57. So 57 by 342. Molecular mass is 342. Okay. Into 1000 by VML. V is your 500 ml. So into 500 into R. R is 0.082 into T. 0.0821. T is your 500. So here 500. 100. So 100, 1000. Here 10, 57, 342. Here 6. Okay. And here 6, 203. So how much? So 10 into 0.08 to 0.8, here 100. So 82.1 into 2 by 3. Okay, 82.1 into 2 by 3 equal to 164.2 by 3 equal to 3 5 is 15, 5, 4. 4 3 is 12, 22, 7, 3. 73 atm pressure. 54.73 atm pressure. Answer.